Hello students, in this video we'll discuss the internal rate of return. If we're given a series of cash flows let delta be the difference of the cash inflows and the cash outflows at time t. Okay. We said the internal rate of return just IRR for short, is the solution of the equation net present value I equals 0. Okay? Now I'm saying the solution, that's a little bit sloppy because there's many solutions to these IIR equations, but we're going to be very concentrated on the only positive one, which is greater than -1. Okay, so when I say the, I want to find conditions under which there's only one meaningful solution to the IRR. Okay? All right, and so what does this mean, of course? So this means there might be a lot of cash flows. So remember that the net present value of I is really what? It's the sum. Let's say t goes from 0 up to time t capital, so your time starts at 0 and goes all the way up to some final time t capital. And typically we think of these things as annual rates of return. So t is going to start at the year 0, to year 1, to year 2, all the way up to the final year tt. So this is really our final year. Final year of what? Of delta t, the change in the cash flow, the change in the inflow and the outflow, over 1 plus I to the power t. Okay? And so if we set this equal to 0, what's oftentimes beneficial, I'm going to write this in the following way. This is really delta 0 plus delta 1 over 1 plus I to the power 1 plus delta 2 over 1 plus I squared, all the way down to the last one, delta at time t over 1 plus I to the power t. So that is what the net present value is. And if I want to set this equal to 0, what we're going to have is we're going to have a polynomial equation. So if we set this equal to 0, so NPV net present value I equals 0, I'm going to clear all these denominators by multiplying 1 plus I to the power t by everything is equivalent to saying delta 0, 1 plus I to the power t, plus delta 1, 1 plus I to the power t minus 1, all the way down to the last one, which would be delta t, has to be equal to 0. And what this is over here is this is a polynomial equation in the variable I, right? So this is a polynomial equation in the variable I, or 1 plus I if you like. So it's a polynomial equation in I. We know that polynomial equations of degree t have exactly t solutions. So there are actually t solutions to this equation. There are t solutions to this equation. How do we reconcile that with wanting to find one internal rate of return? Typically what we want is we want to find situations in which this polynomial only has one value I, for which I is bigger than -1, for which this would make sense. So there's conditions under which that's true. We'll discuss those in future videos. Let me give you an example, though, of when we can do this in a particular case. So I'm going to give a series of cash flows. So here are our cash flows. So let's suppose, so given cash flows, so here we have it. We have time. Here's our time and our delta t. Let's say at time 0, we have time 0, time 1, time 2, time 3, and time 4. At time 0, we have -10,000. Then we have 2,000. We have 3,000. We have 4,000. And then finally we have, let's see, so I have a 3,000. That's going to give me a what? 7. Let's do another 3,000 over here. Okay, so we have We have a 2,000 cash flow in year 1. We have a 3,000 cash flow in year 2, a 4,000 cash flow in year 3, and a 3,000 cash flow in year 4. And so what equation we're going to have over here, we're going to have the equation negative 10,000, 1 plus I to the 4th power, because now we flip the number 4 goes over here. And then we have a plus 2,000, 1 plus I cubed, plus 3,000, 1 plus I squared, plus 4,000, 1 plus I, and then finally plus 3,000 with nothing, 3,000, and we set this equal to 0. So it's a 4th order polynomial, and it turns out that I know that this is going to have exactly one positive root over here. So one root will be bigger than negative 1. And so it turns out for this 4th degree polynomial, you can plug this in the computer and you can check that the only solutions for this, the only real solutions, are I is equal to negative 1.4 approximately, and the other solution is I is equal to 0.04. Okay, so those are the two solutions that we get from this. And now I have to stop and look and see if they make sense over here. So this first one over here corresponds to a negative interest rate. Well, theoretically, those rates are possible. Those costs of capital are possible theoretically in deflationary environments. They're not more common. So we focus in on this one over here, this I equals 0.04. That corresponds to a 4% internal rate of return, which says that you should actually consider investing in this project by spending $10,000 to expect that stream of cash flows. If the interest rate is 0.04, that will give you a net present value of 0, which means that if you get either slightly bigger or slightly smaller than that, you can expect the net present value to go up or go down. So now the question becomes how is this net present value changing with I? Is it increasing with I or is it decreasing with I? That is the next level of analysis, but this tells you exactly when the net present value is 0. That's when that's when the project will break even, and then it's actually sort of feasible to understand if the project is doable or not once you're at this particular internal rate of return or this cost of capital. Thank you very much.